In this lesson, we are going to be learning how to simplify rational expressions. Notice these are all rational expressions. We're going to jump right into lesson practice today. Rational expressions are expressions above and below a fraction bar. And to simplify rational expressions, what we have to do is find common factors from the top and the bottom of the fraction bar. And then when we find those common factors, if there's a common factor that's in everything on top, and then that same common factor in everything on the bottom, if I have a common factor on the top and bottom of a fraction, what can I do? I can cancel out common factors. Now, we're going to find out today that there are some pretty complicated expressions that have common factors. Do you remember that lesson we did recently on factoring out using the greatest common factor? That's what this lesson is going to be all about, too, except now we have fractions involved as well. Now, you may look at something like this 16x minus 7 over 5x. And you may think, hey, can't I cancel out that x that's on the top and on the bottom? Well, here's the thing you have to ask yourself if x is a common factor of everything on top so we can factor it out. Can I factor an x out of 7? I cannot because there is no x in that term. And therefore, I can't cancel the X on the top and the bottom. It's not in everything on the top. That is the biggest, trickiest thing in all of this is you have to know when not to cancel. Sometimes they give you something that looks cancelable and it's not cancelable. All right, and there's one other note here. If you look at A, B, and C, none of these have common factors on the top and the bottom. You know you don't have any common factors on the top when only one term has an x in it, and then the coefficients are incompatible with each other. So, because of that, I can't factor any of these. But if you read the instructions, we're not supposed to factor A, B, and C. We're supposed to do something else. We need to determine the values for which each of these rational expressions is undefined. Hey, from here on out in algebra, anytime you write an expression that has variables in the denominator of a fraction, even if it doesn't say to do so in the directions, you should state the values that the variable cannot take on because your expression will be undefined with those values. So, for example, in letter A, I know that x cannot be equal to 0. Okay, that's how I'm going to state, that's how I'm going to list the values for which the rational expression is undefined. What I'm going to state is the proper thing to state is that your variable in your denominator is unequal to whatever would make your expression undefined. Now, it might feel like it's always going to be 0, but let's take a look at B. In B, if x is 0, my denominator is 0 plus 8, 8, which is fine. So I have to ask myself, what value is going to make this denominator 0? Do you see how what I could do if I wanted to is I could say, okay, x what would make x plus 8 the expression equal to 0? And then when I solve for this, whatever value I get, x cannot actually be that. I'm going to subtract 8 from both sides. X equals negative 8. Okay, so if x equals negative 8, my expression is undefined. So actually what I have to say is x is not equal to negative 8. And I would circle that as my answer for what would make this undefined. Okay, so if you are ever in doubt, just set your denominator equal to 0 and calculate the value of x that would make it 0. Letter C is a prime example of this. This one's really hard to figure out. I mean, it's not too bad, but it might be a little bit hard to figure out what value of x makes this 0. Okay, well, let's figure this out. So I'm going to add 42 to both sides. So 6x equals 42. That's part of getting x on a side by itself. Divide both sides by 6, x equals 7. But wait, if x equals 7, my denominator is 0. So my real true answer for this is x cannot be equal to 7. Otherwise, my denominator is undefined. All right, now here we're going to get to the bread and butter of this lesson. We need to simplify these rational expressions. And I can pull any arrow out of my quiver that I have to figure out how to do this. Now, I'm just going to say some algebra students at this point, you're still novices when it comes to factoring expressions. So you may want to use the greatest common factor method to factor your numerator, factor your denominator, and then see if you can pull out any common factors. And if you have the same common factor on top and bottom, those are going to cancel out. And a lot of times, again, when you see lesson 43 questions, you're going to find that some pretty complicated fractions simplify to pretty simple fractions. But also, you'll sometimes find that complicated looking fractions sometimes can't simplify at all. So let's take a look at D and figure out what kind of problem that is. So on the top, one of my terms is 7x. If I factor that, I get 7 and x as separate very separate things being factors being multiplied together. That is the simplest. That's my prime factorization for that. 7 can't be broken down. X can't be broken down. What about 27? Well, 27 can be broken down to 3 times 9. 9 can be broken down to 3 times 3. It's 3 times 3 times 3. Hey, does 7x have anything in common with 3 times 3 times 3? No, there's nothing in common. I can't factor 7x minus 27. So 7x minus 27 over 5x is already in its simplest form because I can't cancel anything off the top and the bottom. If I can't factor anything out of the top, I'm never going to have the same factor on the top and the bottom. So this already is in its simplest form. But now the other part of the problem, I need to determine the values for which x is undefined. And for that, I have to say that x cannot equal, and in this case, it's going to be 0. Because if x were 0, the denominator would be 0. All right, let's take a look at letter E. Let's see, for letter E, here I have on top 3 times x in one of my terms. In my other term on top, I have 3 times x. Oh, looky here. There's some circling I can do. I can circle this 3 and this 3. Okay. And then in addition to that, here, let me just do that. And I'm also going to change the color to red so we can see it a little better. I can circle this x and this x. So I can factor a 3x out of my numerator. And let's see what that's going to give me. I'm just going to put the the factor term down here. So I'm going to put a 3x out front, open parenthesis. And let's see, in my first term, I had an x left over. I have a minus sign in between. I have to preserve that minus sign. And then in my second term, I circled everything, so I have nothing left over. That means I have to hold the place with a 1. In my numerator, I'm going to have 3x times x minus 1. What about the denominator of this fraction? Well, let's take a look. So I'm going to do 3, let's see, 9x squared is 3 times x. 15x is 3 times 5 times x. What do I get to circle? Well, I'm just going to bring this down. Let's see, I have a 3 I can circle, and I have an x I can circle. And I'm going to tell you, it's a good sign if in both the numerator terms and the denominator terms, I've circled the same things, 3x, 3x. Okay, so that means on the bottom of this thing, I'm going to have 3x out front, and it's going to be 3x times whatever I've left over in the first term, 3x left over in the first term, plus, I have a plus in between, so I'm going to preserve that plus, 3x plus, and then I have a 5 left over in the second term. Okay, and that is how we do it. So this is my new fraction. Now, do I have the same thing on the top and the bottom of the fraction? Any factors that are the same? X minus 1 is a factor, but I don't have any x minus 1s on the bottom. 3x plus 5 is a factor, but I don't have any 3x plus 5s on top. But I do have a 3x here and a 3x here that are going to cancel because I have the same factor on the top and the bottom. So my answer for this problem is going to be x. Whoop, hold on. Let's get rid of that fraction bar. We'll restart it. It's going to be x minus 1 over 3x plus 5. And that's going to be my new fraction for uh, the simplified fraction. Can't factor it any further. All right, now, what values is x unable to take? Well, I can figure that out by just setting 3x plus 5 equal to 0. This is going to be a complicated one. So I'm going to subtract 5 from both sides. I get 3x equals negative 5. X equals negative 5 over 3. And what that means is that my fraction or my x value cannot be negative 5 over 3. So I have to actually state that in better terms. Because remember, I was just calculating what x had to equal to make it 0, but what I really should say is x cannot equal negative 5 over 3. Otherwise, it's going to be undefined. All right, I've got 2 more to do. Let's do those over here. And let's see. So first we're going to do letter F. Whew, this one's going to be another doozy. Let's see. 4x and 28. So 4x is going to be 2 times 2 times x. 28 is, let's see, it's 2 times 14. 14 is 2 times 7. 2 times 2 times 7 is 28. I could make a factor tree if I wanted to. All right, I'm just going to borrow these circles from over here to note that I am going to factor out 2 times 2. And I'm just going to note also 2 times 2, it can be simplified to 4. So I'm actually going to factor out a 4 from the top. I wonder if I'm going to factor out a 4 from the bottom, but it doesn't look like it. How's this one going to work out? Let's find out. So it's going to be on the bottom, 3 times x is my first term. 21 is 3 times 7 times x. That's my second term. Let's see. So on the bottom, I'm going to factor out a 3 because I have 3 in both terms, and an x because I have x in both terms. All right, but these are not the same on the top and the bottom. What's going to happen here? Well, let's explore this one. So on top, I'm going to have 4. And then if I factor out a 4, what's left? X plus in between 7. X plus 7. And then on the bottom, let's see. On the bottom, I'm going to have, let's see, I'm factoring out a 3x. So I'm going to put 3x up front. And then what's left? X. I have a plus in between 7. All right, do I have any common factors on the top and on the bottom? 4 and 3x don't match up, but x plus 7 and x plus 7 do. So that means that I can actually cancel out this x plus 7 on the top, and then also this x plus 7 on the bottom. And this is one of those where I was talking about where something pretty complicated turns into something pretty simple. Because in the end, what am I going to be left with here? 4 over 3x. That's it. That's my new fraction once I've simplified it here. So let me just get a fraction bar in here. 4 over 3x is my answer for letter F. Just by inspection here, I noticed that x cannot be 0 because 0 is the one that's on the denominator here.